Okay, hello everyone, happy to be there. Yes, you're still sleeping. It's almost the end of the day, be strong. So welcome. First of all, if you want to follow the presentation at your own pace, you can use the QR code or access the URL. And please don't forget to join us on Slido with the hashtag DevOps 2019 if you want to ask questions. So don't worry, we will have the same QR code at the end if you want to have it at home at the end of the day. 1, 2, 3, next one. So hey, I'm Damien Duportal. You can find me here on the internet. Do not hesitate to reach me if you have any question, misunderstanding, or anything else. I'm working for Content House, a tiny company mainly based in France but distributed, that build an open source product and its enterprise counterpart named Traefik. So we are majority of technical expert and we are growing. So before I jump on my, hey, my tool is good, blah blah blah, vendor talk, first of all, what problem do I want to solve? Or why did we build Traefik? So as you may already noticed, you have a lot of evolution since the last 3 decades in the way we do the architecture of our platform and services. So recently, we had that trend of the microservices that gave us the promise that, hey, by splitting your monolith in tiny set of services, you will have less maintenance burden, you will have more capabilities, you will be faster to deliver and updates, and a lot of more promise. Okay, everyone know what happened when you start to do microservices. You discover new problems that you didn't even thought about before. They start to rise because by shifting the pattern, you encounter new context and such new problems. One of these new problems is how to locate the service. At a given moment in time, when I have a request entering my platform, how can I know if that request should go to the version 2.0.5 of the service A inside the backoffice, or the same version but on the other backoffice, or the next version because we are doing canary deployment, but yet we fall back to the previous version because of a bug? How can we manage to route this request from outside to the right service inside your platform? We are not the first there. Since the last 8 years, the amount of tools that helps you to overcome this challenge, and not only this one, have exploded. We have so much tool, from containerization, orchestration of these libraries to use inside your own language to find the application, to do the routing, the pattern, the circuit breathing. You have so much tool that the most difficult part is to choose the tool as for today. But all these tools have one weakness: configuration file. For each new tool, you have to learn again a new configuration system, and you have to write it, and you have to template it, and you have to update it and maintain that configuration. So I'm sorry for the YAML lovers. That's a kind of joke that the best way to write YAML which is valid is using, a rule on your screen, so you're sure that the indentation is always the good one. Sorry for that. So this is where Traefik enter. The idea of Traefik says, okay, you always have to write a bit of configuration file, that's right. But what if you had that tools that allows you to not write this configuration at least 80%, because the information is already somewhere else on your system? This is where Traefik enter. Traefik is at the entrance of your platform, hence the name Edge Proxy or reverse proxy, like Nginx or HA proxy. And its goal is to route the request coming from the outside domain inside your platform. A word about the Traefik project. First, it's open source, MIT license. You see an issue, You want to change a behavior? Be my guest. Fork the repository, do the change, and propose it. Or do whatever you want with your fork. That's totally open. That's the core of Traefik. It helped us to gain a community of persons with good ideas, new way of using it, and improving it all the way. It's written in Go, the Golang language from Google, because it has a very good community, a lot of libraries, and it's low level enough for a reverse proxy. So it's quite popular. We have a very big amount of contributors. So we are not Kubernetes yet. But still, it's quite dynamic. If you even reach for help, you will have not only containers, but also a huge community ready to help you. So do not hesitate. Let's dive a bit inside the core concept. So we know what problem we want to solve. Being able to easily route the request from outside to inside without having to write as much configuration as we can. We want to avoid that, to spend our energy on only the important things. So that diagram is only marketing. It's a bunch of cool stuff to show to marketings. But we are here to understand how this is working and how we help you to solve the problem. So let's open the box and jump inside Traefik. For that, I will take a single example. One domain name for one website running inside one Docker container and one instance of Traefik. So I think on the screen it's not rendering exactly, but between Traefik and the Orange cloud, it's written, you have a line that you are not seeing on that screen. It's written auto discovery. This means that Traefik will auto-discover its parameters and reload and dynamically configure itself based on what it can find inside Docker. That's the core concept. So step one, we need to tell Traefik what are the providers of application that you need to route the requests inside. So you need to connect Traefik to Docker, Kubernetes, Azure Service Fabric, whatever, Mesos, Marathon. And once it has that knowledge, which means credentials and an access, it's ready to fetch informations. You still have one thing at least to configure. You have to tell Traefik which port it's going to listen on, because it depends on your configuration and this cannot be guessed by fetching the provider. So that's the only static information that Traefik requires inside a configuration file or a command line flag. This is the entry point. You can have multiple. One entry point say, I have one port, one way where the request will come, whatever domain, whatever content of the request, and some associated properties. Do I want TLS termination on that entry point? Do I want pure HTTP? The second concept is here only for your knowledge, because you don't have to care about that. These are the backends. The backends maps an application running inside your backend system, hence the name. The backends objects are generated and maintained and updated without anything for you to do. It's extracted by fetching the provider. For example, a Docker container has an IP and an exposed port. So Traefik watch the Docker API, and when the container restart is rescheduled somewhere else, it will get the IP and port and will materialize that as a backend object. So you can send requests to that. It's totally automated, and you can have multiple backends from multiple providers, and you can load balance when you have multiple backends for the same app. Finally, the third concept is how do we connect the request entering the entry point and the backend routes that goes outside. These are the front ends. The front ends are objects that say, okay, I received the request. Let's analyze that request, eventually change it, and route that request to a backend based on a rule. The rule could be, if you come on that domain, with that path, with that element, with that header, then go on that backend. If that's another header, go on that other application. These are the routing rules. The object containing that is the front end. By the way, you can also change the request, rewrite the path, remove some stuff, add some headers. That's where everything happens here. That part is almost automated. When I say almost, it's because you don't have to tell Traefik these rules. Traefik will guess or fetch these rules from the provider. I need your attention now. This is really important because it means that the developer or the person deploying the backend application are now providing the information saying, okay, we have Jenkins. Let's deploy Jenkins as a backend. I want Jenkins to be reachable on that hostname, on that path, with that authentication. These are meta information, labels, that are deployed with the service. So then Traefik only fetch this information and infer and create the rules for you. This means the person in charge of the reverse proxy don't have to maintain these rules or receive requests for updating the configuration. You don't have to do that. It's now the responsibility of the person building the application. This means you can give full context to the developer. This has a real huge impact in the way the teams interact when you start having siloed team. That's really important. You give back to the developer the full context of execution in production environment. So, at a glance, I have an incoming request in HTTP. Let's say we do TLS termination. It enters through the entry points. It's analyzed and eventually modified at the front end and sent to a backend service. That's a reverse proxy, except that a few parts only have to be configured manually one time at startup. For the rest, Traefik infers almost all front-end and backends from the backend provider. Okay, these were concepts. We still have an engineering background, so we like to see some code from time to time. I am sorry, there won't be demo because the network was too flaky. So it was really hard to show you the demo with automatic certificates. By the way, on the repository containing this, we have all the code if you want to have it. Yeah, example here. I've lost the internet. Hey, don't worry, I got a backup. Okay, better. So, let's see Traefik in action with some snippet of code. Can you raise your hand if you are not at ease with Docker and Docker Compose? Raise your hand if you don't know Docker. Okay. Okay, so raise your hand if you don't understand from a high level what is this snippet about. Okay, I assume that it should be. So, in that case, I define a new Docker Compose service named OnTreePoint. It's just the name I chose. It could have been Proxy or Web or whatever. That service is based on the Traefik image, version 1.7, which is the latest stable. I passed a few flags. It could be a configuration file written in TOML, but in that case, I prefer the flags. That pass some information, that static configuration to Traefik. We are telling Traefik to use Docker as a provider, hence the -- Docker option, and we mount the sockets, the Docker socket, so Traefik can communicate with the Docker engine. Warning, don't do this in production, please. Matter of security, you don't want anyone to mess that. It's a demonstration. In production, you should have credentials to reach and protect your Docker engine. End of the parenthesis. So it's a basic Docker Compose service with a few flags. You start it, it's written in Go, it starts in 1 or 2 seconds and start watching Docker. You saw that I've put a flag named Acme. Acme is a protocol to request certificate to Let's Encrypt or other certificate provider. That means you have a complete protocol to say, hello, I would want a TLS certificate for my website on that domain name. You request that to a public provider. Let's Encrypt is free. And then that protocol will have a lot of steps before delivering you the certificate. Traefik is able to talk with any Acme provider. Let's Encrypt is the most obvious one. So Traefik generates the certificate and renew the certificate automatically for you with just 3 options on the command line. It takes care of everything. You don't even have to think about that certificate. And it's free with Let's Encrypt, so you don't even have to think about that later. One of the main points of Let's Encrypt is the challenge. When you request a certificate, you have to prove that you are the person you seek to be. So for that, Let's Encrypt or any Acme provider will challenge you to prove your identity by putting a UID on a random path on the web server. So you have 3 kinds. One will be on a HTTP page that will be deleted after with a unique name. It could be TLS, so it tries to connect in HTTPS to your web server, and inside the certificate during the uncheck there is the token inside the certificate information. And the third one is through DNS. It challenges you to create a DNS record with the token, and then Let's Encrypt verify that, and once it's okay, it sends you the certificate. Whatever challenge you choose, once you receive the certificate, Traefik clean everything automatically, install the new certificate, and you're ready to go. So you have to wait 1 or 2 minutes and you already have an HTTPS. You don't even have to generate it or install it or search Google and Stack Overflow to remind what is a PEM, what is a CACert, etc. You don't have to care. Just say I want TLS and let Traefik do his job. Then I told that the developer have the responsibility to deploy the application and say, oh, one is going to reach my application. Here is the second Docker Compose service. It's a web server with static files. It's based on Nginx. And you only need a label that say, hey, here is the rule on the front end. Do you remember the front end? That's the middle. So the rule is written on the place on the provider, Docker here, where you deploy the application. And the rules say, every request coming with the hostname www.mycompany.org will have to be routed to that web server application. You start that container and that's all. Traefik will match the front-end rule and will connect and start routing traffic to that application. As a good reverse proxy, you can even start to specify rewriting the requests, because your backend application might have different issues. Example with Jenkins. As Jenkins can be hard to manage when you had Jenkins on a path, /Jenkins, you need to tell it to be served under /Jenkins. But you already have deployed a web server on the same hostname, so you need a second rule that say, if the request come to mycompany.org and is on the path /Jenkins, then you send it to Jenkins. Otherwise, you send it to the web server we saw previously. So here the rule is a bit different. It says, whatever domain, if you are on /Jenkins, let's use this one. In that case, the URL will be exactly the same. If you enter with /Jenkins, you will exit with /Jenkins. So I have to tell Jenkins of that. Fortunately, it's able to manage that. But then you might have a different issue, like in that case Git server based on Git, it's not able to manage the context, the /something. It's always serving under /. So you have to rewrite the request on the go. So it's easy. Since it's a common pattern, we have a common modifier in the rule. The rule here say, whatever hostname the incoming request have, the path prefix script will capture only on /Git server and will remove that inside the request. So you have the comments that show the result of the rewriting on top. One label. About the second label, there is an issue with Docker container when they expose multiple ports. Traefik is automated and dynamic, but how can it guess if you have two ports, which port to use? What will be the information to help? In that case, you have SSH on the port 22 for that Git server and HTTP on the port 3000. So at that moment, the person in charge of that application must make that rule explicit. It says, if you enter my application on that port, it will be for web pages, and on the other port, it will be for SSH. And what you want is to say, I want for HTTP, and the label that explicitly say which port to use at the container level. That port is the one once the request is rewritten. Raise your hand if you already tried to configure Nginx with Websockets. So you have to add a bunch of options. I mean, Websockets were in 2019. It works very well with Nginx, but the goal is to say you have a WebSocket application, you don't even have to care. It passed through HTTP, so how to deploy a web application with WebSocket behind Traefik? The same as you would do for any other container. So here we are another example of request rewritten, because my application is dumb in that example, and WebSocket will be enabled with the same default. You don't have anything to do. You don't even have to care. Obviously, it's not only Docker. You can do Traefik on Metal if you don't have this fancy stuff with container or cloud or whatever, plain old machines. You can still provide files to Traefik, and this file, each time they are updated with the list of backends, Traefik will reload itself without losing request. Traefik can be also configured through an API. You can do some posts. So if you have your own system when deploying application, it can send an event to update Traefik without doing anything. Here, Traefik is also a main key part in Kubernetes as an ingress. So if you are not at ease at Kubernetes, we have that diagram that tries to make things simple. The atomic part of Kubernetes is a pod. It's more or less a container where your application runs. Then you have the concept of a service, which is at the layer 4 at TCP or UDP, that say, I have a unique IP and I want to load balance from that unique IP to all the pods composing my application. So here you are, two applications. Each of these applications has two replicas. And finally, in Kubernetes, you have the concept of ingress. It's a way to express these routing rules that say, if you enter my Kubernetes cluster on that hostname, you should send request to the service A or B or whatever. So Traefik is one of the implementation of the ingress. You can install Traefik and will have a single entry point for all your Kubernetes cluster, and Traefik will know how to deal with Kubernetes. It's a provider, it watches the API and auto-configure itself based on the events. So you install it one time in Kubernetes and then you just have to deploy your application and stop thinking about the reverse proxy. So remember I said we don't want configuration on YAML, yeah? So here is some configuration with YAML because it's fun. So that's an example. If you know already Kubernetes, it's totally easy. You describe these rules and Traefik auto-configure itself. So there are so much other things inside Traefik that I couldn't cover everything here, from tracing to monitoring to API, managing of DNS. A lot of features are already inside. I wanted to focus only on the basics one to let you know about that tool. Two last things. First, the herd. What if Traefik as a single binary goes down? You cannot manage to send the request to your backends time for Traefik to be restarted and being in shape. That's why we made it distributed. Spoiler alert, I removed my open source hat, and I put my engineer that need to eat at the end of the month hat. This is an enterprise edition. The goal is to provide high availability. So if one of your nodes goes down, the traffic is distributed across the other nodes. Whether you are on Metal, on virtual machines, on Swarm, or on Kubernetes. Also, it provides you safety. You need credentials to configure Traefik for Let's Encrypt, for your backend provider. You don't want this credential to be on a place where you have external requests incoming. So we split into two components. Components responsible for configuration management to put on the private part of your cluster, and another part that takes care of forwarding elements. Finally, with this in mind, it provides you auto-scalability. That means if you have a burst of requests, this node in charge of forwarding the request can scale time to handle the burst and scale down to not consume too much resources on your clouds. So here is how it works. It comes with support, and we provide you a cluster of Traefik that manage certificates in a distributed system. That's exactly the same. It's built with the open source. It's almost as simple. We try to abstract away a lot of things. So we have one command line for management. You install the cluster, and then you deploy the routing configuration. And then Traefik watch Kubernetes swarm or your system and auto-configure itself, except it's distributed and highly available. If you want to try it, it's free. It's still on GA. It will be valid for 2 months, and then the 1.0 version will start, and then it will stop being free, of course. So do not hesitate if you are interested. Break it and give it feedback. Yes, but it's open source. Let me take my hat open source and give you an interesting thing. Yesterday, we released the first alpha for version 2 of Traefik. So it's been 3 years in version 1, and it's the first version ever in that project that has breaking changes. The goal is to adapt Traefik to the newcomers in the cloud, the new way to do Kubernetes and future serverless, and with all those new tools, new challenges appears. So we try to keep the pace. As a developer advocate, I'm really proud of that we have a revamped documentation, because the version 1 documentation was really hard for newcomers. So we have spent a lot of time in a new documentation with organizational and examples. It's clearer with diagrams, so you are not lost searching for a reference. We clarified the concepts, name changing, and we put upfront some elements. So basically we changed the backend and frontends to router and services, and we made upfront the rules and middlewares. These rules were complicated to handle. Remember that label in my example. Now you have an expressive syntax that you can do for handling really complicated case. Like if the request come on the normal API with /v2 or the new DNS, whatever entry point, then it will be sent to the same backend. That's a quick example. Middlewares are pieces of software that will change a request on the go. If you want to rewrite it, if you want to enable authentication, whatever. These are reusable pieces, and it's a kind of workflow for the request. And you can even create sets of middlewares. So you can say production is 1, 2, 3, while on staging is just 3. And you can reuse it across all the routing system. It's an end-to-end relationship. So you can do almost whatever you want. And finally, the big announcement. Now Traefik with version 2 will be TCP and layer 4 compliant. UDP is currently being worked. If you are interested, please help us to make UDP a reality. But now we have TCP as well as HTTP. So you can send traffic not only to your web server, but to any SSH or even database if you want. It's full distributed load balancer. You can even reuse the same port and do SNI routing. In that example, I have HTTPS request incoming. First case, TLS termination at HTTP level. Second case, TLS termination at TCP level, because Docker secured or MongoDB secured. Third case, you just pass through. You still have the Let's Encrypt certificate at Traefik level, but you pass it without decrypting to the backend, and you let the backend deal with the certificate. So you can do client-side authentication with certificate, for example. There are so much more new things inside that new version. So instead, I've just put the blog post. So try it if you're interested. Do not hesitate. We need feedback. It's a community. Again, it's open source. It's not my product. It's not my company product. It's your product if you are interested. Contribution is not only coding. It's also documentation, opening issue, explaining your case or your issue. So feel free to join us and to use that product. That's the end for me. We have plenty stickers. Feel free to take some. Oh, by the way, we are hiring. And we are not only French with an awful English accent. There are real person also that speak good English. And thank you very much. You can find me in the internet. You can get the slides here. And they might be also available on the conference. So thank you very much.